Okay, so this lesson is going to be over a standard form of a quadratic equation, so it's going to look like this, which you should be used to from Algebra 1. Last time we did vertex form. This time we're going to be doing standard form, so ax squared plus bx plus c, so all of your equations should look like that. Otherwise you need to get it into the form like that, and then we're going to be talking about how to get it into vertex form. Okay, so our AOS again stands for axis of symmetry. And if we have our y equals ax squared plus bx plus c equation, our b and our a come from our equation there. And remember, our axis of symmetry is always that dashed line that cuts our parabola in half where we can mirror it. Okay, our vertex is going to be taking that negative b over 2a and plugging it in for x. Okay, so we'll get our y value out. So remember, our vertex is always our highest or lowest point, so we'll be solving to get that point there. Okay, if for our y-intercept, we're going to be plugging 0 in for x. So if we have y equals x squared minus 2x plus 6, if we plug 0 in, 0 times anything is 0, so those go away. So we got 6 as our answer, so our point where it'd be crossing at is 0, 6. Or you could just look at that c value and make your point. So if it's crossing at 0, 6, 1, 2, 3, 4, it would look something like, well, it'd be a happy face. So it would look like this. So it's where it's intercepting your y-axis at. Okay, so we're going to graph this. So right now, let's make our A, B, and C. So my A, B, and C are always the numbers in front. So A is 1, B is 2, C is 3. My AOS is always x equals negative b over 2 times A. So x equals, my b is positive right now, but it needs to be negative because we're putting in for negative b over 2 times my A value. So negative 2. 2 times 1 is 2. So right now my AOS is at x equals negative 1. So it should be a dashed line at negative 1 like so, that blue line. My vertex, I take whatever I just got from my x equals negative b over 2a, and I plug it in for x. So if I plug that in, I got y equals, oh my goodness, negative 1 squared plus 2 times negative 1 plus 3. Negative 1 squared is 1. 2 times negative 1 is negative 2 plus 3. 1 minus 2 is negative 1 plus 3 is 2. So that point then that my vertex will be at is negative 1, 2. So I go left 1, up 2. So it should be right here. Now let's figure out our y-intercept, so where it crosses the y-axis at. So I plug in 0 for x, or I can just look at my c value. Okay, so if I'm plugging 0 in for x, my y-intercept or my y-coordinate is going to be 0, and then look at my c value, so 3. So I don't go left or right, but I go up 3, and then I can mirror that point like this, and it should be a happy face because it is a positive a. Okay, so then we would have a minimum value at my vertex value, so negative 1, 2. My domain is all real numbers. If we were doing range for this, it hits at the y value of 2, and I want everything bigger than it. Okay. If we're converting something from standard form to vertex form, so that's when we're trying to get it to look like this. So first off, we do our x equals negative b over 2a. So we got x equals negative b. Well, it's already a negative 4, so when I put it in for negative b, it becomes positive. 2 times my a, because a equals 1, b equals negative 4, and c equals 6. So then I have 2 times 1 is 2, so I have x is equal to 2. Then we're going to plug it in for x into our original equation to find our y, so we can get our vertex. So y equals, we plug that 2 in. So, oh my goodness. 2 squared minus 4 times 2 plus 6. 2 squared is 4. Negative 4 times 2 is negative 8 plus 6. So we got 4 minus 8 is negative 4, plus 6 is 2. So that point, my vertex point, we're going to plug in right here, so it is 2, 2. And then we're going to make our vertex equation. We already have the A is 1, so we're just using the A from the original equation. Okay, so we got y equals A from the original equation, x minus my h value from my vertex here, because remember it's always hk, so 2, plus my k value, 2. And then we have to make sure we add the little squared on to the back end, because we're talking about quadratics. Okay, so here's our next one. So A is negative 1, B is 4, and C is negative 5. So first we plug it into our x equals negative b over 2a, because we're trying to find our vertex. So first we find our AOX, plug it in to find our vertex point, and then we can create our equation. So we have x equals negative 4 over 2 times a, negative 1. So we got 2 times negative 1, which is negative 2, so 2. So I got x equals positive 2 for my AOS. We plug it in to find our vertex. So y equals negative 2 squared plus 4 times 2 minus 5. 2 squared is 4 plus that negative on the outside, so it is a negative 4 plus 4 times 2, which is 8, minus 5. Negative 4 plus 8 is a positive 4. A 4 minus 5 is a negative 1. So my point then is 2, negative 1. That's my vertex, so my highest or lowest point. And now we can create our equation. So y equals, we use the a value from the original, so negative 1. X, it's a minus sign. We always remember our h is always the opposite of what we think, squared, and then my k value. So there's my vertex form for that one. Okay, my next one. A is negative 2, B is 8, and C is 3. So I got x equals negative b over 2 times a. So negative 8 over negative 4, so 2. So x equals 2. There's my AOS. Got to find my vertex. 8 times 2 plus 3. 2 squared is 4. 8 times 2 is 16. Negative 2 times 4 is negative 8. Negative 8 plus 16 is 8. 8 plus 3, 8 is 11. So my vertex this time is 2, 11. So I got y equals my a value, which was negative 2, x minus 2 squared plus 11. Remember, whenever we put our h value in, it's always the opposite of what we think. Okay. A is 2, B is negative 5, and C is 12. So I got x is equal to negative b over 2 times a, so x is equal to 5 over 4. So when we plug it in, we got 2 times 5 over 4 squared minus 5 times 5 over 4 plus 12. So I could literally just type this in the calculator. Make sure you use parentheses when you need to use parentheses. And I get 71 over 8 as my y value. So my vertex is 5 over 4, 71 over 8. So when I make my equation, I got y equals my a value, x minus 5/4 squared plus 71 over 8. All right, find the vertex, the AOS, the max-min, and the range. So remember, AOS is that x equals negative b over 2a. This is when you plug the AOS in your point, okay? And then I'll explain max and min. So right now it is a positive a right here. So we know it's going to be a happy face. So it's going to be a minimum value at whatever my vertex is. Min, if it lets me write it, minimum. Okay. Let's go ahead and find our AOS. So x equals, so my a right now is 1, my b is 2 and my c is 1. So x equals negative b over 2 times a. So negative 2 over 2, so negative 1. So my AOS right now is negative 1. There's AOS. My vertex, I need to plug that in to find the actual point. So if I'm plugging it in, I got y equals negative 1 squared plus 2 times negative 1 plus 1. Negative 1 squared is 1. 2 times negative 1 is negative 2. 1 minus 2 is negative 1 plus 1 is 0. So my vertex is negative 1, 0. So that means if I graph this, this would be at negative 1, 0. So my domain is all real numbers. My range, since it's a happy face, we've already decided, okay, my y value that the lowest point is going to be at is 0, and I want everything bigger than that. So that is going to be my range. So we already said minimum, we got our range, we got our vertex, and we got our AOS. Okay, so A equals negative 1, B equals 2, C equals 1. So this time it's a negative A, so it's going to be a sad face. So this time I'm going to have a maximum at whatever my vertex value is. Okay, so let's do our AOS first. So x equals negative b over 2 times my a. So negative 2 over negative 2, so 1. So x equals 1 is my AOS. We plug it in to find our vertex. So y equals negative times 1 squared plus 2 times 1 plus 1. So 1 squared is 1, but this negative on the outside keeps it at a negative 1. 2 times 1 is 2 plus 1. Negative 1 plus 2 is 1. 1 plus 1 is 2. So my vertex then is 1, 2. So if I did my sad face, my vertex would be at 1, 2. So when I'm doing my range, so this is my max value. When I do my range, I want everything less than my y value in my vertex, so 2. So there's your AOS, your vertex. Your max point was at whatever that vertex value was, so 1, 2. And then we found our range. Okay, so we got A is 3, B is negative 4, C is negative 2. So it is a positive A, so it will be a happy face. Oh my gosh. So this time it's going to be a minimum. So when I'm doing my x is equal to negative b, so it's already a negative 4, so when I plug it in, it's going to be a positive 4 over 2 times a. So we got 4 over 6, which simplifies to 2/3. So that was my AOS. X is equal to 2/3. So when I do my vertex, I plug that in to get my point. So y is equal to 3 times 2/3 squared minus 4 times 2/3 minus 2. So when I type that in, make sure you have parentheses. So I get negative 10/3. So my vertex then is at 2/3 negative 10/3. So that is what my minimum value would be. And if my graph looks like that, my range then would be my y value that my vertex is. And I want everything bigger than that, so I'm going to eat the y.